Hey everyone, Grant K for the Flame Learning channel. In the previous video, we started looking at physical-based rendering in action. We covered the core concepts of PBR and image-based lighting, and went through the workflow of applying physical-based shaders in the 3D scene. This allows you to simulate real-world materials and lighting, and create realistic results extremely fast. In this video, we pick up from where we left off and look at the Pbr Shader Node in more detail. We'll also look at the workflow of using the PBS Maps to customize your PBR materials with images instead of numeric sliders. This opens up loads of creative potential, including the ability to have localized variations of PBR values within the 3D geometry's texture. This is something you cannot do with only a shader node. This will make a lot more sense when you see how PBS Maps function in action. The model I am currently using is courtesy of TurboSquid. You can purchase this model and many others by visiting their website at www.turbosquid.com. Now I'm using my Action 3D scene from the previous video. Here we have a 3D geometry that is using the physical-based rendering shader pipeline, and it is being lit by image-based lighting. Using a 2-up view and looking at the action schematic, 2 PBR shaders are being used to shade various parts of the 3D model. Now let's take a closer look at the shader node that controls the lion head and mount box geometry. The shader is set to physically based, and this enables the PBR shader pipeline, where roughness and metallic are the main influences for the shader model. We went through those parameters in the previous video, so I'll skip over them for now. Underneath them is the Subsurface Scattering. This parameter controls how much light is absorbed by the texture and scattered out at different points. In real-world use cases, this would help with such textures as skin, marble, leaves, liquids, and more. Please note that if a texture is very metallic, it would reflect more light as opposed to absorbing it. And because of that, subsurface scatter will not work in that case. Next, the specular level value represents the Fresnel specular reflectance at normal incidence for the dielectric model. Dielectric model refers to a material that isn't metallic, so it has a metallic value of 0. So you have some subtle control over this parameter, but it only works within physical accurate terms based on the PBR model. You can't exaggerate it, and you can't completely turn it off, as that would not be physically accurate. The specular tint allows more of the base color information into the specular highlights instead of just white. Once again, this is also a very subtle change and is non-existent when the material is very metallic. The anisotropic parameter and angle parameter control a light source's representation as it's reflected in the texture. For example, I'll make the 3D geometry less rough and more metallic. Now switch back to the Action Node bin and drag out a light node. You can see the light source reflecting in the texture. Now if you start adjusting the anisotropic parameter and its angle, you can see how the light distortion can be controlled. This is very useful when creating certain metals and vinyl, and controlling how light should behave correctly with those materials. But I do want to point out that this only works with action lights and not image-based lighting attached to the camera. Finally, you have the emissive parameters that allow you to control the intensity of light emitted from the material. This can be used with or without any 3D scene lighting, as the texture is emitting its own light. This can be used for glowing effects, blooming, etc. So these are all the parameters that are currently available in the physical-based shader node. Now all these parameters have 2 things in common. Firstly, they globally affect the PBR texture. And secondly, all the parameters are driven by a numeric slider. So if you want to do more visual work and be very intricate, then the next step up from the PBR shader is to start using PBS Maps. This will allow you to drive PBR texture components based on an image, and this includes the freedom to localize the effects of any PBR parameters. So let's totally isolate the texturing of the lion head and mount box from the rest of the 3D model. Break the material connection between the box and head geometry nodes and move them closer together. In the result view, the ring, teeth and eyes will remain as they were. Now let's apply a fresh material node to the two geometry objects. Hold Ctrl and draw a rectangular selection over the two geometry nodes. In the Action Node bin, locate the material node and drag it into the action schematic. Now standard shading uses the diffuse map to texture a 3D geometry. But when it comes to texturing a model with PBR shading, you should use a base color map. Both the base color map and diffuse map represent the core colors of the material, but they are distinctly different from each other. A base color map usually shows the colors of the object without any lighting, so it's normally quite dull looking. A diffuse map, on the other hand, shows the colors as well, but normally lighting is baked into the texture. Now, since both maps are essentially the same thing, we do not limit you to using the diffuse map or base color map with the PBR shader. However, the general rule of thumb is to use diffuse maps for standard shading and base color maps for PBR shading. With all that said and done, let's texture this geometry with the PBS map. So ensure the material node is selected in the action schematic. In the Action Node bin menu, select the texture for the geometry and switch to the Maps tab in the Node bin. Here you will find the PBS map object. When you drag it out, it will attach to the selected material node. Now at this point, nothing happens. So let's find out why. Double-click on the PBS map for its controls. At the moment, the parameter of the material is undefined, so the PBS map does not know what to do with the associated media. Click the pull-down menu. The workflow is that you can assign one PBS map for each parameter in the shader node. So you can have multiple PBS map nodes in the schematic, each doing different things. So the first operation is to tell the PBS map what parameter it will affect. Change the option to base color. The model should now look the same as it previously did. However, the parameters of the PBR texture are now separate, allowing for more intricate work. So you can have multiple PBS maps attached to the material node, and each one will control a different parameter of the PBR shading. In the next video, we'll look at examples of how to isolate a section of the PBR texture, as well as completely change the look of the texture with the various PBS map material options. Be sure to check out the other features, workflows, and updates to the Flame 2017 Extension 1 products. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Learning channel for future videos.